joining me today about this talk where I discuss AI and API and sort of recent trends and how they sort of have what they have to do with each other. Let me introduce myself. I'm Timo Rüppell. I'm the VP of Product at Firetail. So we're an API security company, and I won't really spend much time talking about our product in this talk. If you're interested, go to firetail.io. Or hit me up on LinkedIn or somewhere if you're interested about details around API security. So previously, I used to be a theoretical particle physicist, but now I do actually hard stuff like API security. And I'm a Helsinki native, and it was a great joy to have API Days here in Helsinki and represent my home city. So in this talk, we're going to go through some analysis on sort of the recent rise of APIs and AIs and what that sort of means for APIs. And overall, I'll try to leave you with a sort of slightly more broad understanding of what is happening in the AI field, a little bit more depth to it than just what's sort of the top headlines in the news around large language models. So that gives you a better understanding and will sort of drive home the point that we're trying to make here. Then we're going to take a look at the risks, both from the API and the AI sides, how these two different fields affect each other. And then finally, we're going to do a small threat modeling exercise, which I think is, again, sort of trying to drive home the point about how you prepare for AI when you're operating an API and sort of charged with API security. So let's start with sort of the rise of AI and API proliferation. API proliferation, I think, is sort of accepted and well understood, hopefully with at least the crowd that's listening to this video. There's been a large shift towards cloud computing and serverless architectures, shift from monolithic applications to distributed microservices, and also sort of splitting off non-core business items like payment processing or fleet management or what have you. And all of these sort of architectural shifts and sort of this movement towards individual pieces all having to talk with each other via APIs, right? So what I want to do is now take a look at the other side, which is the sort of recent growth in AI. And sort of just to preface this, I myself am sort of slightly AI skeptic and partially AI optimistic. So there's I think valid reasons to be both skeptic and optimistic with regards to this new technology, and I'll outline a little bit more during this talk about that. So ChatGPT is now 1.5 years old, and that is quite remarkable if you think of it. I mean, new technologies can do fast takeoffs, but ChatGPT took 5 days to reach 1 million users, which you can compare to, for example, Facebook, which took 10 months, or Twitter, which took 2 years, or Instagram, which took 2.5 months. So the question is sort of what is different about OpenAI and about ChatGPT. And then the other thing that I want to also point out here is that very recently OpenAI has announced new capabilities for their large language model, for their ChatGPT product, specifically with regards to APIs and interacting with APIs. But so let's take a look what sort of changed. Why is this now becoming big news? Because AIs have been around for decades already. We know that it's been an academic research topic since the 60s, and we've had machine learning, a subset of that, since the 80s already in practice, and even neural networks have been around since the early 90s. But none of that sort of caught fire until we had ChatGPT or DALL-E or Midjourney. And one thing that I think has happened here is that we did hit a sweet spot where the cost of compute and some advances in math made it so that it became cheap enough to be good enough, right? And so what I would say is that sort of is one of the enablers here, but the other thing that enabled the sort of explosive growth of ChatGPT and OpenAI is business model innovation. And this is sort of, if you believe in the Christensen models of disruption, like business models is usually the foundation of disruption, is a new business model. And so the business model that OpenAI has taken is this sort of direct to platform model. And this, I think, is really crucial, not only because I think it has produced a wildly successful business for them, but it is interesting because as a direct to platform model, this immediately invokes the existence of APIs, which is interesting for us, right? But the sort of thing is that with this sort of model of direct to platform, which is a very sort of microservice age company kind of thing to do, if you compare to like these other companies that I mentioned, like Facebook, Google, and Twitter, which are sort of from the age of monolithic applications. This direct-to-platform model has yielded an immense influx of companies that are basically just repackaging a slightly retrained or slightly tweaked OpenAI ChatGPT model. And so the thing is here that the business model then leads to these sort of architectures existing, right? Where this is now not our original research, this is from Andreessen Horowitz. And the thing here is that you normally think about a product or a SaaS service as maybe some endpoints or a few endpoints. And with ChatGPT, you would normally just think about, okay, I send a prompt and then I get a response. But there are many, many more APIs in this sort of stack model where you have the model being orchestrated and run, and you've got APIs for, tweaking the model, for prompting, for setting up data and managing stuff. It is all in all a very sort of evolved complexity level of API, right? And sort of what I want to leave you with is that the sort of AI as a business model shift from previous new tech innovations here, right? And in particular, native to the distributed service architecture paradigm. And that means that it's not only natively an API first service, but it is also an evolution of the complexity of that API that you're going to interact with. So the next thing that I want to turn your attention to is sort of the breadth of the subject matter of AI. So LLMs are currently in the sort of center stage, and they're the poster child for AI. And you might be too focused on sort of a particular aspect of AI technology, in particular LLMs, and that can blindside you to sort of the full impact. So while most discussion is about one or two LLMs, there are serious advancements being made all the time. I already mentioned the fact that LLMs themselves, like ChatGPT, is getting API calling capabilities, but there are, just to mention a couple of other interesting different categories of models. Large action models are built to take human speech and turn them into AI actions. API actions, and this is a good example is Rabbit AI, which is a company that has a small sort of assistant product, and they're basically using LAMs to help that assistant, book travel plans or buy flowers from a flower shop or what have you, right? Another interesting aspect is sort of large content and behavior models for intent. And these sort of models are trained to take intent into account and sort of work in a way that gets a desired action happening, right? And so right now they're trained against sort of for human behavior. There's a company that is doing healthcare and trying to get you to be healthy. But you can immediately see how this could be used for social engineering, for example, or if you're sort of switching and combining these two aspects, you could have a thing where you're actually telling the AI, I want a user account on this service now, and I want a second user account on this service, please. And now I want you to test if you can cross-pollute the resources that these people create or sort of access them, testing for bolas, for example. So the second big idea I want to take away is that AI is broader than LLMs. More specific models can be much better at performing certain tasks, and also that this is already happening all around us. It's sort of like seeping into everyday technology all the time. And it will continue to do so, even if some individual AIs might be not up to snuff yet. So next, let's focus a little bit on the future. So although ChatGPT is revolutionary, quote unquote, and you can argue that it's disrupting search at the very least, I do think sort of the disruption of AI itself is still to come. So there's a few things around this that make me think this. First of all, there's the sort of compute aspect. We're still on the slope of Moore's law. There's the math aspect. Advancements are being constantly made. There's recently a research paper that basically managed to cut down training costs, not just by an order of magnitude, but by moving from n squared to n log n. And people who understand what these cryptic things mean understand that this is quite a big advancement. And obviously also specialization. So you're going to get more and more specific use cases, which are going to be more and more easy to handle for specifically trained models, right? And so I believe that AI models will become commodities in the long term. And sort of arguably some AI models are already commodities. You can go at Hugging Face, which has a bevy of over 700,000 AI models for you to choose from. But even large models will become commodities. And commodities, again, interestingly for us, are usually interchangeable and broadly available. That's two common traits of commodities. And these two, again, these basic structures mean that there's APIs, because interchangeable technology needs standard interfaces, and that will be APIs in this case. So this all leads me to posit two very separate things. So firstly, either already or very soon, pretty much everyone, everywhere, regardless of expertise, will have access to API testing or API interaction capabilities. And it'll be up to the model whether this is, benevolent or can be used maliciously. And the other thing is that regardless of almost of what kind of service you're operating, you will be integrating with AI technology in the very near future. So with those two things, let's talk a little bit about understanding the risks of this new sort of environment that we're moving into. And I've divided these to go from one side to the other. So let's first talk about AI risks affecting API security. So the very big one is obviously unsafe AIs. And currently, AI operators are making sure that their models behave in a sort of safe and well-defined way. And again, it's good to understand that the models themselves are unsafe, and they will continue to be unsafe for as long as data is being used to train them that might contain unsafe things. And obviously, that's sort of like a logical problem there that you can't really go around. But it might be that in the future, again, with commoditization and technological advances, older models are left lying around, and maybe some people with not so good intentions get access to them. Or there might be organizations that just straight up front the cash to train adversarial models, for example. So that is one thing that is going to be a concern. The other thing is if your API is dealing with human-generated content, then already obviously you need to have sort of filtering and validation in there, and you for certain services you need to have trust teams, etc. But even if you're just sort of running a product review site, for example, you need to be prepared to deal with large scale abuse of your product. And the tricky part is that this is going to be almost indistinguishable from true human behavior, which makes it sort of like doubly important that you build in some architecture components to help you deal with this instead of just trying to band-aid the situation. Finally, there's access control, which is about sort of the AI doing things and not understanding authorization. There's a recent research paper on Office 365 and Copilot, where the researchers managed to show that a Copilot enabled Office 365 user could access other users' personal data, for example, like salary information, because in the sort of team space that was available to the AI, and the AI didn't understand the sort of access restrictions of the information that it had learned from the sort of cloud environment. The other way around is also quite interesting. So basically, you could say that all API risks are eventually AI security risks. But a couple of them stand out. For example, injection attacks. Injection attacks are still extremely prevalent and a major cause of incidents for APIs, just classic SQL injection attacks. And so the thing is that this translates into AIs, because when you're integrating your product with an AI, you have to somehow safely take the user intent and transform it into a prompt for your AI without the possibility of prompt injection, for example. There is resource consumption, which obviously is already an issue if you're running an API, but if you are running an AI integration, those integrations usually are still very costly. So while you may not be concerned when you're running like a blog or a comment site about sort of extraneous costs, when you're running an AI integration, you do need to make provisions for metering and rate limiting so that you can curb overuse of those features. Unsafe consumption of APIs is a good thing to keep in mind. So this is in addition to the authorization stuff that I just said. When an AI model prepares some data for you to return to the user, you should make sure that that data that the AI returns is actually safe for your backend to handle, and it's also safe for the user to handle. And this can take various different kinds of forms, this sort of safety checking. And finally, there's a good old classic server-side request forgery, which is a classical thing where you can trick the server to access resources that it shouldn't access, directory traversal, for example. And in the way where you are integrating with, let's say, a couple or three different AI models in your backend to do various different tasks, you also want to ensure that when a user uses a feature or when a user uses your API, that it can only interact with those models in sort of safe and predefined ways. So with those sort of like risks in mind, let's take a look at some sort of best practices for securing APIs in the age of AI. We like to divide the security field in these sort of 6 different pillars of API security. Discovery and visibility is where it all starts. It's a classic saying that you can't secure what you don't know about. And then next is sort of observability and assessment. So when you know your APIs, you should observe them and you should make security posture management decisions, whether they're configured correctly. And the observability and assessment part is something where we're sort of very sort of positive in thinking that this is something where AI can actually help you with. And then finally, there's enforcement and audit. And I want to now take a little bit of a tour around enforcement here, which is our next sort of little threat modeling exercise. So this is just a sort of schematic of an API call where a consumer, requests something from an API and goes through a gateway proxy and then into a server and gets a response returned to them. And I'm going to use the OWASP top 10 for APIs here as a sort of a threat model and see where these items land in this API call. We're going to discard number 8 and 10, which are sort of around the entire management of the API and setting up of the API, because those don't really affect an individual API call's security features. First off, there's broken authentication, which is usually outsourced to a third-party authentication provider, but is handled at the server layer. Then there is the next stage, which is unrestricted resource consumption and unrestricted process access. Now, these are the two items where sort of traditional network security will help you via firewalls and rate limiting, for example. But more often than not, in modern services, this has to be done in the server at the application level with proper validation and in the business logic. A good example here is GraphQL, for example, where it's not so much about guarding against repeated 10,000 requests per minute. It's more about an individual request consuming too many resources, exfiltrating too much data, and getting sort of those threats in there that way. And then there's the sort of the triplicate of authorization failures, and these are all obviously dealt with in the server. And then finally, there is the server-side request forgery and unsafe consumption of APIs. Now, when you look at where all these are, and I've now here marked also the ones that we just talked about being sort of in the context of AI. These are all at the server level. These are all in the application layer. And it is obvious why, because these things need access to request and response payloads in order to make these sort of authorization decisions, for example, right? So when you're thinking about where do you put your efforts in guarding against AI threats, you need to put your efforts in the application layer. Traditional network security doesn't help you very much, and that's just because it doesn't have access to the required metadata for making these security decisions. Like, so whether you're looking at VPC flow logs or sitting at the gateway, you're always missing out on request parameters and the payloads for the request and the response. So I'll close out with the bottom line here. The scale and the risks of and the frequencies of attacks are going to grow due to AI. But the good news is that the nature of the threats, while it is evolving, it still carries along the same core risks and sort of the sort of same remediations are there as well. And that's all I have for you today. Hope you enjoyed the talk, and I hope I'll see you on our website or get messages from you in LinkedIn. Thank you.